Alright guys, welcome to our week 11 College Board review help video. So I'm going to do problems that look like your problems on the College Board there, and hopefully they'll help you get your problems done. Alright, so here's an implicit function, and I want to find its derivative. So let's begin. So I want to take the derivative of arcsecant of x equals y to the negative 2. Now the derivative of arcsecant is weird. It's 1 over the absolute value of x square root of x squared minus 1. And whatever's here is what goes in this spot here and this spot here. A lot of times if there's more than just an x in here, you'll have to multiply it by the derivative of the inside also. But we don't have that on this problem, it's just an x. So it just comes out nice and clean like that. Okay. Now for this one over here, we can just do our power rule. We can multiply the front by a negative 2 and take 1 away from the power like that. And we want to also remember that when you take the derivative of y, you always get a y prime. And y prime is the same thing as dy dx. So I want to solve for dy dx. That means I just need to get this by itself. So all I really need to do is just divide this to the other side. But before I do, I think I'll rewrite it a little bit. Since these are multiple choice questions, it does matter how we write our answer. And so I think they'll probably not have a negative power present if they can avoid it. So there's that. Now if I want to get y prime by itself, what I would do is I would multiply both sides by the reciprocal. Y cubed over negative 2. And so these cancel, and my final answer would look something like this. And there it is. So just do your implicit differentiation. Don't forget your y prime, and get that y prime by itself. Let's go ahead and move on to our next question. This one is probably the most tedious one on the worksheet today. So let f be the function defined by this, and let g be the function defined by this. The line that's tangent to the graph of f at x equals negative 2 is parallel to the line tangent to the graph of g at x equals a. Which of the following is a possible value of a? So stop and try to think about what this question's asking you to begin with, okay? Because you can't really answer the question until you ponder what it's talking about. So we're talking about two functions. Now I don't have any idea what these functions look like. You don't need to write this. I just want you guys to observe it. But let's just say that this here is the graph of f. And then we have another function, g. Let's just say that this is the graph of g. Well, they kind of look the same. Maybe I should make them look a little bit different. Yeah, I'll make that g. Okay? So we have these two functions here, and it says at x equals negative 2, f has a tangent line there, which I'll go ahead and make that a red one, right? So f has a tangent line at negative 2. Now it says that g has a tangent line that's parallel to this red tangent line. So can you guys find, where would you sketch a tangent line on the g function here so that it's parallel to the one on the f function? Well, I would probably put it somewhere over here. That way those two red lines look about parallel, right? And we want to find out at what value of x does that happen at? And that x is what they're calling a. So basically, to do this problem, I need to figure out what is the slope of this tangent line, because if this one's going to be parallel to it, they have to have the same slope. And so what I really want to do then is, how do I find the slope of this tangent line? Well, I need to find the derivative of f at that number. And then I need to find the derivative of g at this number, because that's the slopes of those tangent lines. So the slope of f at negative 2 should be equal to the slope of g at a, if those lines are parallel, because parallel lines have the same slope. So here's what I'm going to do on this problem. I'm going to find f prime of negative 2, and then I'm going to find what value of a, what value can I plug into the derivative of g to actually get a parallel line there. All right. So now I'm going to be doing all of this on my calculator here. So let me bring up my graphing calculator. Now the first thing I'm going to do is I'm going to type both of my functions into the calculator. So I'm going to go to y equals. I'm going to put those functions in there. So we have f of x is going to be sine of x squared plus 3x. And you guys should do this along with me so that you can kind of get used to pushing the buttons before you start doing it on your own. And then we're also going to do the g function. I'm going to go down and type the g function into the next line down. 6x cubed plus 4x squared. All right, so there's that. Now I'm going to get out of there by pushing second and quit. Now, as I told you guys before, what I want to do is I want to find where does f prime of negative 2 equal g prime of a. Well, the first thing I'm going to do is I'm going to find out what f prime of negative 2 is. Okay, so we want to find the derivative of the f function, which I stored under y1. I want to find the derivative of the f function at negative 2. So how do we do that? Well, to find the derivative of the f function at negative 2, I'm going to push math. I'm going to scroll down to number 8 where it says derivative, and I'm going to type x. I'm going to put the y1 function in there, which is the f function. So I want to find the derivative of the f function at x equals negative, and don't get your negative button mixed up with your minus button, negative 2. And there it is. So that's a weird number. There it is. So the slope of my f function at negative 2, or the slope of its tangent line, in other words, is 0.416. Okay? And so now I want to find, for what value of a does g prime equal the same thing? That way it'll have a parallel slope at that point. All right, now, there's a few ways that we could do this. I'm going to go with an easier approach for now. This is a multiple choice question. And that's going to make it a little bit easier for us. There's ways to do it without multiple choice, but I'm going to show you the multiple choice approach for today. So here are my possible answers I'm going to offer you as a possibility. Maybe A is 0.912. So let's see if that works. I'm going to do the derivative of the g function at 0.912. If I do that and I get this, well, then that's the answer. Now remember, the g function is stored on my calculator as y2, right? So let's keep that in mind. So I'm going to do the derivative again. Math, 8. And this time I'm going to put y2 because I want the g function. And I'm going to type in this possible answer, 0.912. All right, 22.267. Well, that's not the same as 4.16, so that's not it. So we know the answer is not 0.912. Let's try the next one. Let's try 1.319. Now, so I don't have to retype this whole thing. I'll show you guys an interesting little trick. If you just push second and then enter, it brings up the last thing you typed in, and you can go back and just delete whatever you want and replace it with whatever you want. So I'm going to replace the 0.912 with 1.319 and push enter. Is that the correct answer? No, it's still not 0.416. So let's try the next one. I'm going to push second and enter and bring it up again. Let's try typing in the next option, which is negative 0.49. Negative 0.491, my bad. And for that one, I get 0.411. Now, that's pretty darn close. That's pretty darn close. So that's probably the answer. When it comes to these types of problems, we're rounding a lot. And so that's probably going to be the answer. But I'll check the last one just in case, just to make sure that maybe it's not a better answer. Let's try. Second entry, and I'm going to type in, the last one was negative 3.331. Yeah, that's definitely not it. So the answer is C. So we're going to go with the one, the value of A, that gives us the closest value to 4.416. So let's review the process here. I have two functions, and they each have a tangent line. And I want to find, I know that one of them has a tangent line at negative 2. I want to find out where should the tangent line be on the other function so that they're parallel. Parallel means they have the same slopes. So if their slopes are the same, then these two things would have to be the same. I found this on my graphing calculator, and then I plugged these into this until I found where they actually match, and that would make them have parallel slopes. Right? Now there's a way to do this without without multiple choice as well, but it requires a few other skills that I don't want to overwhelm you with right now because this was kind of challenging enough, I think. But let's go ahead and move on to the next one here. Number 3, use the table below to find h prime of 2 if h of x is equal to that mess. And just so you guys know, a lot of the problems on today's College Board review assignment are going to be product rules because that's just what I chose to focus on for this week. So here we go. This is like my A, and this is like my B. So if I want to find h prime of 2, the first thing I need to do is find h prime of x. And it is a product rule. So we have A prime times B plus A times B prime. All right, so what's the derivative of A? Well, constant multiples just stay there. The derivative of f is f prime. And the derivative of a constant just goes to 0. Next, we're going to put the b in there. Then we're going to put the a in there. And then finally, b prime. The derivative of a constant goes away. There is a negative 1 in front of that g, so that's a constant multiple that'll stay, and then we have g prime of x. All right, so now I want to find, after you find the derivative, you're going to plug in the number that they give you. So we're going to plug in 2 now. All right, and from here on out, we can just use our table to simplify this a little bit. F prime of 2 is negative 3. G of 2 is 1. F of 2 is 2. And G prime of 2 is 5. So we have 5 times negative 3 is negative 15. 2 minus 1 is 1. 5 times 2 is 10. Minus 3 is 7. And negative 1 times 5 is 5. And we have negative 15 plus 35. Final answer is 20 if we put the negative 15 together with the 35. All right, so basically just find the derivative first using the product rule, and then use the table to plug in. All right, guys, let's take a look at number 4. On this problem, it says the graph of two functions, f and g, are shown below. And then they tell us about a third function, p, which is a product of those two functions. And the question is, what can we conclude about p prime of 2? And they give us some options. So, as you guys can see, either p prime of 2 is equal to 0, less than 0, greater than 0, undefined, or maybe there's just not enough information. Let's go ahead and see what we can figure out here. So if I want to find p prime of 2, the first thing I want to do is I want to take the derivative of p, which is going to be the product rule. So we're going to have the derivative of the first function times the other function plus the first function multiplied by the derivative of the second function. A prime b, a b prime, right? Now I want to find p prime of 2. So I'm going to plug in 2. Now, you'll notice that we're talking about zeros here, and the reason for that is because we're probably not going to be able to get any exact values, but we can definitely determine whether the outcome is positive or negative. So let's do this one here. F prime of 2. Well, here's f, and f prime is the slope. Now, what do we know about the slope of the graph at this point? Well, it's positive because it's going in an upward direction, right? Let's look at g of 2. G of 2 would be probably like right about here. Now, that's below the x-axis, so this is the y value of the g function. And since it's below the y-axis, we know that that's going to be a negative value. Plus f of 2, that's a positive value because f of 2 is up here, and f of 2 is the y value of the f function. So since it's above the y-axis, we know that it's going to be a positive. And then finally, we have g prime of 2, which is the slope of the g function at 2, which is right here, and that's negative. Well, a positive times a negative is negative. And then a positive times a negative is negative. And if you add two negatives together, you end up with a negative. So here's what I know. I know that the derivative of p prime of 2, I don't know what the number is, but I know it has to be negative. And therefore, p prime of 2 would have to be less than 0. So that's how you're going to have to handle this type of a problem. So you're going to look at, you have to remember that primes are slopes and non-primes are the y values. And just determine whether each value is positive or negative and simplify it. Now, it could turn out you get one where you really can't figure it out, and that would be not enough information. Okay. If I would have told you, for instance, that both of these were positive, well, now you wouldn't have enough information because I don't know, even though I know this is positive and this is negative, I can't tell you whether the outcome is positive or negative because it really depends on which one of these is bigger, and we don't know that, right? So it is possible to not have enough information, but in my case, it was because anytime you add two negatives, you always get a negative. So, but that's basically the process. Just going to think your way through it there. Let's move on to number 5. For number 5, I'm not going to do any examples for you. I'm just going to remind you, look at your 2.14 notes. And just remember if all the rows are parallel, then that means there's no x. If all the columns are parallel, that means there's no y. And you might want to take note of where the zero slopes are located to see which one of the differential equations would have that. Same thing with undefines. And then finally, if none of those things are enough to get you to the final answer, just pick a few points to see whether the slope should end up being positive or negative. But let's go ahead and move on here to number 6. An equation of the line tangent to the graph of f at this point is what? So I want to find the equation of a line tangent to that function there. So to find the tangent line, we need three things, right? We need an x, we need a y, and then we need a slope. And once we have those three things, we can do our little formula here. So here's my x1 and y1. They just gave those to us. Nice. Sometimes they make you find the y yourself by plugging it into the original function, but so far today we've had two problems where they don't do that. Next, we need to find our slope. Now, to find your slope, you need to find the derivative of your function and then plug in your points. So let's start by finding f prime of x. So here we go. This is going to be another product rule. We have an a and a b. So it's going to be a, b, prime, and prime. Here we go. A prime is 3. B is x squared minus 1 to the 4th power. A is 3x. And b prime, this is going to be a chain rule to find the derivative of b. Okay? We have the outside function, which is the 4th power. And then we have the inside function, which is x squared minus 1. And so the derivative of the outside is going to be 4 parentheses and then cubed. And the inside stays the same. And then the derivative of the inside is going to be 2x. So there's my slope. Well, that's not my slope. That's my derivative. To turn it into a slope, I just need to plug my x value in now. So here we go. All right. So negative 1 squared is 1, and 1 minus 1 is 0, and 0 to the 4th power is 0, times 3 is 0, so that whole thing just becomes 0. Plus, this is negative 3 times 4, which is negative 12. And once again, we have another 0 here, and then a negative 2, and that just becomes 0 also. So on mine, the whole thing comes out to be 0, and that's my slope. All right? Now we have our x, we have our y, we have our slope. We're ready to write out our equation. So it's y equals 0 times x minus a negative 1, which really just makes it become plus 1 and then plus 0. Now you could simplify this. Since if it's a multiple choice question, you want to distribute your 0 in. And 0 times anything is 0, so we really just end up with a weird looking tangent line. It's y equals 0. And that's it. You could leave it this way if we had an FRQ, but these are multiple choices, so you're going to have to simplify it. All right, let's go ahead and move on to number 7 here. If y equals tangent x sine x, find y prime of 3 pi over 4. Once again, another product rule, AB. So we have our little product rule we need to go through. A prime is secant squared x. B is sine x. A is tangent x. B prime is cosine x. And now we're going to plug the value in to find our y prime of 3 pi over 4. All right, so you might want to use your trig reference sheets here. All right, so cosine of radical 3 over 4 is negative radical 2 over 2. Tangent of 3 pi over 4 is negative 1. Sine of 3 pi over 4 is negative radical 2 over 2. And then secant squared. Let me ponder here for a minute. Secant is the reciprocal of cosine. And then squaring would be 4 over 2, which is 2. So it's going to end up being 2. All right. And then we can go ahead and simplify this because it is a multiple choice, right? So this 2 is going to cancel this 2 when you multiply them together. So I'm left with just negative radical 2 there. And we have our plus. And then putting these together, we have a positive radical 2 over 2. And once again, with multiple choice, they're probably going to want you to have a common denominator. So let's go ahead and get a common denominator for those pieces there. Make some room real quick. All right. So over 1, we're going to multiply the top and the bottom by 2. And that gives me the following. Now, you can imagine there being a 1 here, and negative 2 radical 2 plus 1 radical 2 is negative 1 radical 2 over 2. You just combine the coefficients. Negative 2 and positive 1 makes negative 1, right? So there you go. So you might have to get a common denominator. It just depends on your problem. All right, let's go ahead and take a look at number 8. Let f be a differentiable function such that f of 1 equals 2 and f prime of 1 equals negative 3. If g equals this, then we want to find g prime of 1. And as we've already seen multiple times today, if you want to do that, you got to find the derivative first. And once again, it's a product rule. There's my A and there's my B. So a lot of repetition here today. But repetition helps us remember, right? All right, so the derivative of A is negative 4x. And there's our product rule. Next, we're going to go ahead and plug our numbers in here. We're plugging in 1 for G. All right, let's simplify this a little bit. Here we've got negative 4 f of 1. Here we've got negative 2, so I think I'll just go ahead and change this plus here to a negative 2. And then we could just use the facts that they give us in the word problem to finish it. So f of 1 equals 2, right? So I can replace this f of 1 with 2. And they also tell me that f prime of 1 equals negative 3. So I've got negative 8 plus 6 is negative 2 is my final answer. Let's take a look at number 9. For this one, they just want me to find the derivative, but guess what? It's another product rule. Now, before we begin, I want to remind you guys of something. There's two ways that we've learned how to find the derivative of square roots, okay? One way is we've changed it to a half power. We've multiplied the front by that number and subtracted 1 from the power, which allows us to move that x down to the denominator and then retransform it into that. But the other way I showed you guys was the shortcut. You really just need to know it jumps straight down there to that. We don't need to do all that work. So anytime you're taking the derivative of square root, just know it's going to be 1 over 2 square root x. Okay? It's always the same. Now, for the problem that we're working on, though, it's going to be a chain rule because, yes, we have a square root function, but it has something on the inside, right? So we'll keep that in mind. So here comes y prime. We want to do AB, prime here, and prime here. All right. A prime is 4x. B is this. A is 2x squared. B prime, all right, so this is where we get to do our rule here. So we've got my outer function is the square root. My inner function is the 5x plus 10. So the derivative of the outside is 1 over 2, and then whatever the square root is. In this case, that's 5x plus 10. And then we also want to multiply that by the derivative of the inside, which is simply 5. Okay. Now, how are they going to put this together? I don't know. Hopefully they wouldn't want you to go through and get a common denominator. They might. But for now, I think we can simplify it a little bit. This is a numerator, and this is a numerator. But this 2 is a denominator, so this 2 can kill that 2. So I'm left with an x squared and a 5 in the numerator there. And in the denominator, I have a 5x plus 10. Now, let's see, do we need to go further than that? So I paused the video and I looked at the College Board assignment. They do want us to go a little bit further by getting a common denominator. So here's what we're going to do. We're going to put this over 1, and the common denominator would be this thing, right? So what I'm going to do then is I'm going to multiply the top and bottom of this fraction here by this square root. So I'm going to put 5x plus 10 on the bottom, and then I'm going to multiply another one up here on the top. Now something kind of cool happens here though. Okay? Anytime you multiply a square root by itself, the square roots cancel out and leaves you just with the part that's under the square root, right? So what do I mean by that? Let me explain it. Let me finish writing this first. But basically, the square root just goes away if you multiply a square root by itself. Like, for instance, if you guys did square root of 2 times square root of 2, well, that's the square root of 4, which is simply 2. So anytime you multiply a square root by itself, it just becomes the number, right? So if you do this square root times this square root, you get just the part that was under the root without that actually in there. All right, now we're going to go ahead and simplify this. We're going to distribute this in there. That gives me 20x squared plus 40x, square root of 5x plus 10. And then we have this guy also on the top now. So I put them together as one fraction now since they have a common denominator. And then I can put this 20x squared together with this 5x to get a final answer of 25x squared plus 40x over that common denominator. So on yours, they are going to want you to get a common denominator and put them together as one, and that's how you do it. Let's go ahead and take a look at one more here. So we've got two piecewise functions, f and g, and we've got another function here called h, which is the product of those two functions, and we want to find h prime of 8. Once again, the first thing we're going to do is we're going to find the derivative of h, which is a product rule. No surprise there. Been doing that all day today. And now we want to plug in the 8 that they give us. Now, for these types of problems, you have to remember what does a derivative represent on the graph, and what does a regular function represent on the graph. So a derivative represents the slope. So what this is this is the slope of the f. This is the slope of the f function at x equals 8. So I want to determine what is the slope of my f function at x equals 8. Well, here's my f function. Here's where x equals 8, and what's the slope of the line that that's on? So there's two ways you could do it. You could pick 2 points off of the line and use the slope formula if you wanted to. Or you could just look at the rise and run. To get from one point to another, I would have to go down 3 and right 3. That's negative, rise over 1. Run would be negative 3 over 3, which is negative 1. So that would be the slope of that one. So you can either do the formula or just look at your slope. Okay? Let's go ahead and move on to the next part. Next thing is asking for g of 1. Now that's not a g prime, right? That's just a g. So if you're looking for just a g, that means what's the y value of the g function at x equals 8? So there's where x equals 8, and what's the y value there? Well, the y value at that point is 1. What's this? Is that a y value or a slope? Well, it's not a derivative, so it's a regular f, so therefore that must be a y value. So they want the y value of the f function at x equals 8, which is 3. Lastly, we want g prime of 8. Oops. So g prime of 8, that's a slope of g at 8. So here's where x equals 8. What's the slope of this line? Well, it looks like my run is 3. I'm going to the right 3, so that's positive 3. And up 1, that's a positive 1. Rise over run would be 1 over 3. Negative 1 times 1 is negative 1. And then 3 times 1/3 is 1. And adding those together, we get 0. So there it is. Basically then, for this, you need to remember to take your derivative, plug your number in. Remember that primes are slopes, non-primes are y values. Calculate from there. All right? And that should do it for our College Board review for this week. This one was a little bit more challenging, I feel, than our past ones. So, and that's normal. As we progress, we're going to look at more and more challenging types of questions. But hope it was helpful, and we'll see you guys next time.